ready to start then. Well, this is a bit new for me to chair a session in an online meeting, so I hope everything goes well. But we have already quite 37 people joining, so that's I'm glad we have a large group. So this session is about adaptation pathways and adaptive planning. And we have 3 presentations. And our idea was that we have about 12 minutes of presentations and then 3 minutes questions. And then at the end that we have a bit more discussion among all of us. And I think the best way to ask questions is either to put it in, raise your hand, or put a question in the chat, and that we first listen to the presentation. So we start. We have Lisa Kultje already here, and then is Jens Nieuwik? Are you here already? He mentioned he might be a bit late, and then there is David Gold or Peter Greed as a third presentation.
Yeah.
Okay, good. Okay, Lisa, then I give the floor to you.
Excellent. So I'm going to talk to you today about imagining the unprecedented, developing climate risk storylines. So today we're looking at exploring and explaining plausible climatic events in a warming world. And in the end, I'll tie that into how it connects with the adaptation pathways approach. So we're part of the Climate Receipt project that's part of the Horizon 2020 funding. And we're looking at the remote impacts of climate change on systems in the EU. As you can see from the diagram on the right-hand side, the idea of storylines or climate risk storylines are central to the Receipt project. So from that storyline narrative, we gain information about climatic drivers and climate hotspots, and also from insights that stakeholders can help us with. But the storylines themselves also inform research design, research modeling, and research findings. And all of that in an iterative conversational way comes back to informing impacts and vulnerability and our understanding of climate risk. So climate risk storylines, what are they? They can be defined as a physically self-consistent unfolding of climatic events or pathways that reflects implications for society. And that's really the risk aspect of the climate storyline. This presentation is based on a literature review. We looked at 19 papers that were published from 2015 to September of this year. They all used the term storylines explicitly, but they also had the aim of increasing knowledge of climatic events. So things that were really based on energy use or other narratives or scenarios weren't necessarily included in the review. They were evaluated in terms of their temporal scale, their spatial scale, how they reflected climatic scales, metrics, their impacts, and also their application for society. So climate storylines have been used already to address a number of issues, there's societal issues that relate to climate impacts. So coastal infrastructure, for instance, has been linked to sea level rise in some of the papers, and financial systems and international relations have been linked to issues of rain, risks from storm, and also flooding events. We've also seen papers where the food systems and manufacturing have been linked to risks from drought, from heat, and also of extinctions. So as we went through the literature review, we realized that storylines were really being used in 2 quite different ways that fit together to both explore and to explain. So if you look at linkages of different kinds of methods of analysis, then they were used to explore potential or counterfactual climatic events in a warming world. But they were also used as storylines that were telling the story and would explain what those causal chains describe, including some of their consequences. And so across the storylines, there was a combination of analytical modes and a way to link those together. And there was also a way to link together the descriptions of what they meant. So both exploring and explaining. And these functions enable storylines to link across temporal and spatial scales and really demonstrate some significant flexibility there, to help to manage uncertainty and also to guide co-production. So I'll talk about those three aspects now. It seemed easiest if we took a specific example and walked through it because it makes it more concrete, a little bit less abstract. So thanks to De Bruyn et al. In 2016 for their paper on the storyline approach, a new way to analyze and improve flood event management. So you can see from the image from their paper there that it was centered on the island of Dordrecht in the Netherlands. And click on the right thing. So the temporal scales that they were referring to were hours to days and months. So hours to days related to the amount of time you might get for forecasting of a coming significant rainfall event. Also the development of the climatic conditions that would lead to it. And then of course the event itself, which is meteorological or weather related. So it's very much that small, fine-grained scale. And then months more related to the time it took for water to subside and the very long tail of recovery that might happen in the community. In terms of spatial scales, it's clear that local vulnerability was key, but they also made the links between the global and regional models and those outputs, and they addressed issues of downscaling. So they specifically addressed how those spatial scales were linked all the way from the global to the local. They demonstrated in their paper 4 specific uncertainty approaches, and I'll stress that these are qualitative rather than quantitative because similar to pathways, you don't have to use a quantitative approach with the storylines. So they began by analyzing interdependencies between critical infrastructure networks, and that helped to manage the uncertainties that were available there. They also used rough general assumptions to generate possibilities. So rather than add something in with an uncertainty function, they said, we're going to assume these things and consider them to be certainties. They also included through stakeholder engagement, a preventative action in one of the storylines. So they noticed that there was significant uncertainty because there were actions that might or might not be taken. And so with the encouragement of the stakeholders, they included one storyline that assumed adaptive behavior. They also made sure that the stakeholders were reminded to regard these as examples, not as predictions, and that too was a way to manage uncertainty. In terms of co-production, as I've already said, they had significant stakeholder input that led to an additional storyline. But they also, in their flood event modeling, included not just climate impacts, but also human behavior. Where would people go? How might they travel? When might they go? So looking at these things in more detail, I put it across in a bit of a table, but again, we'll walk through that using the case study as our guide. And if you look on the left-hand side of the table, you can see the storyline focus was either quite immediate and proximate, it could be emergent and evolving, or it could be remote. And part of the RECEIT project is to look at these remote impacts and their implications for the EU. So if we look at the temporal scale for this island of Dordrecht flooding event, again, it's days to weeks. In the spatial scale, it was local as a focal point, but clearly related to both regional and global processes. In the climatic scale, it was hydrometeorological. So we're looking at an intense rainfall event and what it would lead to in terms of rainfall and runoff. And the metrics are important because we do have a conversation in storylines between the quantitative and the qualitative, and so metrics are needed to be able to bring information into models and simulations. And a very common metric in terms of rainfall is an intensity, density, frequency function, and so these IDF functions were reflected in the paper as well. Clearly the impact here we were looking at was flood rather than drought in this instance, and the societal application. So there's stakeholder engagement in the urban and local planning, but also with a nation the size of the Netherlands, management events for events such as this would also relate to national planning. So you can see that we walked through this table in a particular way, and that the other papers would highlight different aspects of this, but this is sort of a grid work to take a look at them. So when we consider what qualitative approaches to uncertainty were shown in the the papers across all of the literature. We've grouped them now according to the stages of the research project in which they were applied. So when looking at the research design initially, part of it was to question assumptions. Do these still hold true in a warming world? Do they hold true for this particular instance? And so to make that explicit meant that the uncertainty was something that could be understood. The same holds true with making the documentation transparent, so that when decisions were made and assumptions were taken up, that was easily communicated to others, both inside and outside of the project. And to invite expert knowledge, because no group of scientists in a particular discipline will know it all. It's important to be open to get information from the community and from other disciplines. So during the storyline development, again, there were two different ways. One is in the analytic mode, where they developed these counterfactual causal chains, where you could look at a historic event and consider how did this happen and take access to that information, but also look at a counterfactual. If it hadn't happened the way it did, how might it be different, for example, in a warming world? And also developing multiple storylines so that it's descriptive sets that are comparative. And that's an opportunity to manage the uncertainty as well. In terms of modeling analysis, and remembering that we're looking still here at qualitative approaches, one of the methods was to reflect plausible climatic evolution and to look at some of the more extreme examples. Also to apply multiple methods so that they could be triangulated, to ensure that key drivers are included, and not just the climatic ones, but all of the ones that could be identified, and to identify dependencies so that you understood where there might be multipliers that would increase uncertainty or impacts. So these were a number of the different approaches across the papers that were used to manage uncertainty. In terms of co-production, stakeholders, as we've seen, can inform the research questions to co-produce new knowledge, but it wasn't always the case. In projects where they were mainly looking at understanding climatic features, they might not have engaged with stakeholders, although societal needs would be a motivator. So one of the values of stakeholder involvement is that focusing on these rare and unprecedented events, their imagination might be quite necessary to identify what are the surprises that would be the most relevant for them in terms of planning and risk reduction. So we saw that societal partners can draw on past experience. As you can see from the image on the left, this is from a workshop on agriculture that RECEIT put on. They might be asked to imagine hazards they've not already faced, and they might be asked to consider risks that they haven't seen in their own experience that are of greater intensity, duration, and frequency. And so that's one of the really important aspects, that imaginative aspect, but well informed because they've got their own knowledge. So in terms of storylines, climate storylines and adaptation pathways, there are a number of similar features. They both have multiple lines of plausible evolutions. They both have interdependence, or independence from calculating probability, although that's certainly useful if it's there. And there's flexibility to reconfigure with new information, which is very important in something as dynamic as climate change. So I'll just leave you by saying that exploring and explaining climatic events in a warming world, climate storylines can inform adaptation pathways to consider plausible, rare, or unprecedented climate impacts that might otherwise be missed. Thank you.
Oh, thank you very much, Lisa. Other questions? If you have a question, you can raise your hand or put it in the chat. Can you put your last slide back on?
Certainly. I know I can. I know I can.
No pressure.
No pressure.
I know. At least maybe I can ask a question then. If you have already considered, or have you used the storylines already to explore alternative pathways? So
the RECEIT project is in its beginning, but with the literature review, we were able to look at storylines that have already been produced. There's a number of papers, and I didn't actually list all of the papers here, although we've just found out that the review will be published in Wire's Climate Change next year. If anybody wants to contact me, I'm happy to give you that list of publications.
Okay, thank you. So, and which paper is that we can that we should read?
What will it be called? I think it's going to be called. Isn't it interesting? You know, you write these things, and it takes so long to come up with the. It's the emergent. It'll be climate storylines is the first words.
Okay. Okay.
But I think if we look at these slides, if I can do it, there we go. I did here. So these are some of the papers that have been reviewed, and I don't have the full list that goes with them. But the particular one, there's a Shepherd et al. 2018 that also gives a lot of good information. And then these have all used storylines as a way to talk about these risks. Any other questions? I'll let you go on to the next person.
This is Doug Samuelson in Annandale, Virginia. I put this in the chat, but it's worth saying. This is a comment, not a question. I've found and been arguing for about 15 years that getting people who are not very quantitative to tell you something is much, much easier in narrative form than trying to structure some form of quantitative input, a survey instrument or a structured interview or whatever. You're applying so much framing bias when you create that instrument, and often inhibiting the response you're looking for. Some of the most important information is they start telling you a story, and you hear something you hadn't thought of, and that turns out to be quite relevant. You never would have gotten that without the narrative.
And I have to say, I've done a lot of science communication, and there's nothing like, well, there's one thing about trying to communicate science outward, but you try to communicate to scientists, and it's much more difficult. So as we get that information coming from stakeholders, it's very interesting to have, if you let the scientists go directly, they'll say, can you quantify that for me?
Right.
And the stakeholders look at them like, that is so much their job, not mine.
One thing that I think has been maybe underutilized in our form of science, you can also turn model output or analytical output into a narrative and run that back by the stakeholder, expert, whoever else, and say, is there anything in this narrative that really doesn't make sense to you? Much more powerful form of validation than almost anything else you can do with SMEs.
Yeah, I would say too, if I've got time.
Interesting.
That,
maybe we should go to
the next
this could be another session.
Again.
Thank you so much.
You know, this is nice. Jens, are you ready to start your presentation?
Yeah, thank you. Thank you. I'm ready. Let's see if this works. Okay. Yeah, thank you. Are you gonna stop the time? Give me a signal.
Yes, I will interrupt you.
Fine.
Politely.
Okay. Great. Okay. Yeah, thanks for having me. That is us actually. So Shireen Malikpour and myself. Shireen can't participate. It's I think 2 or 3 a.m. in Australia right now. So my regards from her. This is a work that we jointly authored and that sort of emerged from a research study that she did last year while with us here at Leuphana University in Lüneburg. Just a brief note on myself, I'm professor of governance and sustainability. So while Shireen has more this background also adaptive institutions, of adaptive planning. Our focus is more on governance, so we kind of joined these two perspectives together in what actually has already become a published paper. So the question here is how adaptive are adaptive planning as applications? So we're really looking at empirical literature. We're trying to give a bit of a response at reviewing the literature that is there, empirical applications of adaptive planning, trying to test a little bit like what is really the quality, what are they really up to, building all of this on the DMDU literature, of course, linking that a little bit to policy analysis, but then going beyond that and merging that with ideas of adaptive governance. And as many of you will know, also the adaptive governance discourse, parts of it has its roots in ecology or social ecological systems. If you wish, the Stockholm Resilience Center is very prominent in that respect. Coming from the idea that ecosystems can only be not be steered, not be guided in a classical way, but only be governed in an adaptive sense. Plus, then we're looking at anticipatory governance that is more oriented towards the discourse of climate adaptation. So what did we do here? We were doing like a little meta-analysis of empirical applications of adaptive planning. We didn't have any restrictions, so it was really like globally, so global as we could find literature. And we assessed how adaptive were those planning applications. But also in the second step, we looked through this literature at would we be able to find like typical or common enablers as well as barriers to implementing adaptive planning. Yeah, you can see here the publication that appeared this year. I'm going to jump to the next slide because here we've got, I can show you how we proceeded in following the PRISMA guidelines for a systematic review. So we started with a Scopus database research, found 818 hits. We screened the abstracts, which was a laborious process, of course, and included in the end 99 abstracts that seemed suitable. Papers like suitable empirical studies that both discuss a planning process for long-term strategy. That was one of our criteria. That discuss adaptation as a key feature approach to planning, and that really is an empirical paper, so not just a normative or conceptual one. While reading the papers, we excluded quite a number of papers again, so we, in the end, arrived at a number of around 40 papers. So assessing adaptiveness, like what is actually adaptiveness, like quite a bit of methodological thinking, of course, behind that. So how adaptive were those planning applications? And we sort of operationalized that into three elements. So on the one hand, we looked at did those applications explore a range of future scenarios, forward looking into the future? B, were those applications flexible in that they were keeping options open, in that they were having like a stage or a phased implementation and so forth? And C, really in terms of like practical implementation, were those applications setting up like monitoring regimes? Like that's the most important. So these three issues we were combining as elements of adaptiveness, and for each of those elements coded a 0, a 0.5 or a 1, depending on whether we thought that is like really present in the study, then it was a 1. If it was completely absent, it was a 0. But sometimes we coded a 0.5 if it was sort of somewhat present. So for each of these elements, we coded separately the adaptiveness, and also came up with a measure of total adaptiveness, which is the sum of individual elements. So overall, from these 40 plus studies, the average observed adaptiveness you can see here. So that was slightly less of half of those cases. If you look at these different elements, so including scenarios, having options ready and monitoring systems in place, we can see that on average, so this is kind of per paper, the average implementation, we're not reaching 1. So every paper has less than that, but element 2 here scores slightly highest. If we look at the geographies, so what countries did we look at? So these numbers here are ordered from left to right by the numbers of cases, not by the score of adaptiveness, but by the numbers of cases. It's maybe not surprising that we've got a lot of US cases here, also a lot of from other English-speaking countries, and then kind of a range of other countries with really varying average adaptivenesses per case that we were actually studying here. If we look at the different sectors, you can also see here that's again sorted by number of cases. So water was the main field of application that we found, obviously, followed by natural resource conservation, and then a lot of other areas that are much less prevalent. So this is not something that we looked for specifically, but it just turns out that those areas are more prevalent than others. And we can see that, and that is really interesting, that average adaptiveness seems to correlate a little bit with prevalence of cases in these sectors, except for energy, but we only have 1 case. So that might be a little bit of an outlier here. Okay, second step, we're looking at the enablers and the barriers in this literature. We also looked at what actually was reported and like how significant was that, and explaining the level of adaptiveness. So here, first of all, the enablers. So this is something that we kind of developed in a somewhat iterative way. So looking at the literature, first, what kind of enablers were described, and then at some point we included these categories as coding fields in our coding scheme. So we went a little bit back and forth, but essentially this is very much coming from the literature, so not essentially predefined categories. So what we find here is that a truly transdisciplinary environment with regular interaction between practitioners and scientists, so bringing in science in a structured way, was like the main observed enabler, and that in 18 cases of 40, so that's quite a lot, I think. And also setting a dedicated governance structure, so having that in place was also a main enabler, and then a number of further enablers, as you can see here on the slides. Those that significantly helped to explain those levels, like that I showed you first, of adaptive planning. Here again, a transdisciplinary environment, dedicated governance structure, long-term commitment to the process, that the process was also championed within organizations advocating adaptive planning, and that those processes were also linked with ongoing institutional processes, which I personally find very plausible as well. So those are not necessarily just the most prevalent ones, but those who are like significantly linked. On the other hand, barriers. So same procedure here, and let me jump directly to those barriers that we found to be significant, and that is here the lack of long-term investment strategies. So might sound a little bit like a textbook kind of thing, so it's not so surprising. Second, the prioritization of the status quo and incremental actions over transformative strategy, also maybe not so surprising. Third, success indicators were defined in relation to delivery and implementation rather than experimentation, learning and adaptation. And fourth, that we found a certain risk aversion towards open uncertainties and options. Also, I think not a surprising adaptive planning. So in the end, what we do in the paper is kind of, that's the last slide. We were trying to put together ingredients like of a good governance system here. So we think it's important to look at the actors, at the network of adaptive planning champions, the science practice exchange, as you heard, and that there are good and dedicated structures in place, governance body, independent peer review, that there are sufficient resources, and that in the end also, of course, the practices and the cultures play an important role. Yeah, so much for a little overview of what we found in this small meta-analysis, and yeah, looking forward to any questions that there may be. Thanks.
Are there any questions? I don't see questions in the chat yet. I was a bit interested in that there were one of the barriers was the lack of long-term investments. So do you mean that there's no a long-term goal, or don't people want to invest in this longer term?
Yes, I think it's rather the latter. So I mean, it's not necessarily a question of goals, but whether sort of there are resources behind this, and maybe if you want to interpret that, it's maybe along the lines of like symbolic claims versus like really putting something in it. And long term, right? So that's not a one shot and like a little project here and there, but that it's meant to be long-term investments.
So to overcome that barrier, what would be needed?
Yeah, I think that it aligns to this element of structures that we looked at, so that there are governance structures in place that allow for these, but it also, of course, has this resources element, right? That resources are allocated, has maybe an economic component if we wish. Yeah.
I see a question in the chat from Richard Moss. Do you want to ask it yourself?
Sure. Hey, everybody. I had to find my unmute button. Great presentation. I'm just curious about whether in your review of the communities and this literature, you had a sense of the size of the communities. A lot, you know, one of the barriers that I noted wasn't included in your list has to do with capacity of a community to kind of do this, both in terms of personnel and kind of sustained ability of personnel to do this work, as well as funding. And we see it, you know, particularly say in coastal areas, small rural coastal areas in the U.S. And I just wondered whether, you know, you had any sense of that.
That's a good point, and I must admit it's been a while since we read through these papers. So as far as I recall, it was pretty diverse, but I'd have to look it up. And this point of whether there's like an association between kind of size and sort of success in terms of adaptive planning, that's a really interesting point, and that's something I just noted down. Maybe we have to look into our data to see if there is any pattern that would emerge from that. We just didn't have that on our radar. Thanks.
Okay, I think we should go to the presentation of David, and then if there is enough time, we can get back to other questions. I saw your question, Lisa. Maybe Jens, you can have a look at the chat to other questions. So we give the floor to David.
Right, thank you. So hi everyone. My talk today is going to be about the challenges involved with developing cooperative adaptation pathways. Oh, my computer's going a little nuts. So the main points in my talk are going to be first, that the stability of cooperative agreements is a critical aspect to the design of adaptive multi-actor infrastructure pathways. Then I want to talk about how we can use exploratory modeling to provide an understanding of the nature of regional conflicts and aid in negotiating a compromise. And then I also want to demonstrate how we can use multi-objective optimization as a tool for exploratory modeling itself to help us understand cooperative stability and reveal vulnerabilities within cooperative agreements. And I'll demonstrate this on a regional water supply planning problem. So regionalization has been a popular topic in water supply planning circles, mainly because historically, at least in the United States, water supply utilities would manage growing demand by independently investing in new supplies. And as time has gone on, investment in new supplies has become increasingly difficult. Here we have a plot of dams in the United States from 1850 to 2000. And one thing we can really see is that the number of viable sites has been rapidly decreasing. So one way that water utilities can try to overcome this is through regional cooperation. And this can happen both on short-term timescales and long-term timescales. In terms of short-term management, water utilities can coordinate the use of existing water sources in times of drought. So if city B has some excess water and they have infrastructure connecting to city A, they can sell some water to city A. And then in a longer term time scale, utilities can cooperatively invest in new infrastructure when necessary. But cooperation brings its own challenges. Specifically, when you have cooperation in a water supply plan, instead of just having to worry about uncertainties, from natural or population growth type scenarios, you also have to think about cooperative stability, which we're defining as a measure of the willingness of different parties to cooperate and the practicality of a cooperative solution. So in order to investigate cooperative stability, we're proposing an addition to the fairly well-known many objective robust decision-making framework for cooperative systems, where we really add a focus in the negotiated design selection part of the framework. And we are also proposing a regional defection analysis to try to understand what are the consequences of a multi-actor agreement. So to motivate a little bit what I mean by a regional defection analysis, we're going to borrow a little bit from game theory. So game theory is an entire field devoted to looking at conflicts across multiple actors. And one of the core concepts of game theory is a Nash equilibrium, which is defined as a solution where there's no profitable unilateral deviation by any actor. So we're not going to conduct a full game theoretic analysis, but we can borrow this concept to try to investigate the cooperative stability of a dynamic and adaptive pathway agreement across water utilities. And specifically, we can actually use multi-objective optimization to try to discover, are there ways that individual actors may seek to defect from a regional compromise? And we'll also introduce a new measure of stability to be able to quantify what are the impacts of defection across utilities and then, or across actors, and then we can use that to learn about the drivers of regional tension in our system. So I'll demonstrate this framework on a hypothetical water resources system called the Sedento Valley. In this system, we have 3 water utilities in close geographic proximity, Watertown, Dryville, and Fallsland. They're all facing challenges from a growing urban demand as well as a changing climate. And they can cooperate in terms of short-term drought management in the form of treated transfers. So all 3 utilities can request allocation from Lake Michael, which is a regional resource. Watertown has a water treatment plant on Lake Michael, and so if Dryville and Fallsland want to access that regional resource, they have to get treated transfers from Watertown. The utilities can also coordinate in the use of water use restrictions to tamp down demand in times of crisis. In addition to short-term cooperation, the utilities can also cooperate in the long term in terms of shared infrastructure investment Specifically, Watertown and Fallsland are investigating cooperatively investing in this new river reservoir. The utilities also have their own infrastructure that they can each build independently, including things like water reuse to use their existing water more efficiently. So these utilities are investigating these cooperative strategies in the face of deep uncertainty, which stems from things like climate change, demand growth, construction delays. And so in order to try to come up with adaptive planning frameworks or an adaptive planning framework to overcome this deep uncertainty, we've employed a adaptive rule system where both short-term drought mitigation decisions, which are made on a weekly timescale, and long-term infrastructure investment decisions, which are made on a decadal timescale, are triggered based on the observed risk in the system. So I always like to think of these decision variables as dials, where we're trying to figure out how much risk should a utility tolerate before they impose water use restrictions, buy treated transfer, or invest in a new infrastructure. So to illustrate what this type of adaptive planning framework might look like for this system, I've plotted from a output of one simulation from 2020 to 2065. This top plot shows the long-term risk of failure. And we're seeing that really in this orange line. And as this risk of failure increases, maybe due to rising urban demand, new infrastructure is triggered when we cross the decision trigger. We then have a construction period, and then the new infrastructure is built and the supply increases. And in between new infrastructure options being built, the short-term risk metric triggers drought management decisions and tries to keep the risk of the system low. And here I'm showing each infrastructure option as a different color. So we start out in the status quo. I'm just coloring that pink. When we trigger the first infrastructure option, we move on our infrastructure pathway to this green area that denotes that the first infrastructure option has been constructed. And then when we build another one, we move to blue. So this pink, green, blue is one example of an infrastructure pathway. This same rule system, though, is going to be adaptive to the states of the world that it observes. So if we observe a more severe state of the world, maybe the demand is higher or the climate is drier, it's going to build infrastructure earlier and more often. And conversely, if we have more favorable conditions, it's going to wait longer before triggering new infrastructure. So this is an example of 3 potential states of the world that this infrastructure trigger could interact with. We can also examine that over many states of the world. So if we were to look at 1,000 states of the world, we could come up with a map that looks something like this, where again, each row on this little plot is one realization of uncertainty, and the colors represent our different infrastructure options that have been triggered. So the next question is, how should utilities choose decision thresholds that define these pathways? So we've defined 5 performance objectives for the utilities. They want to maximize their reliability, minimize the restriction frequency, minimize their average drought management cost, minimize the net present value of infrastructure investment, and minimize their worst case drought management cost. And we're really seeking an equitable compromise across these regional partners. And so since we have 3 utilities and 5 objectives each, we employ a regional minimax formulation that for each objective, we're going to optimize the worst performing utility so that all other utilities perform as well or better in that objective. So our optimization then looks something like this. We have our regional rule system where I like to, again, think of each decision as a dial. And so we have a set of dials for each utility. Those decisions, so one rule system can get fed into our simulation model, which then gets run over an ensemble of 1,000 samples of deep uncertainties. From that 1,000 samples, we can calculate our objectives regionally, and then that gets fed back into an evolutionary algorithm, which can then evolve a Pareto approximate set of portfolios for the region. After we do that, we reevaluate it over a broader set, or we reevaluate each candidate solution over a broader set of deep uncertainties, and we calculate the robustness of each solution. And we can use that robustness to find a compromise for each of the 3 utilities. Here we're doing that using a fallback bargaining strategy. And in many analyses, this could be where we stopped. We have a decent compromise across our 4 utilities, but we haven't really looked into, does this compromise face risk from cooperative instability? And specifically, if there's no binding agreement between these utilities, what are the risks of one utility defecting from this compromise? And so to test that, we have developed a regional defection analysis, where we take the decision variables for 2 out of 3 of our utilities and we fix them to the values of our compromise solution. And then we allow the evolutionary algorithm to search for optimal policies according to just one of the utilities for one of the utilities' objectives. So in this case, we're having the algorithm edit Watertown's decision variables, and it's only being fed back Watertown's objectives. Likewise, we could do that for Dryville and for Fallsland. So this procedure can allow us to answer 3 questions about regional stability. First, do cooperative partners have an incentive to defect from the regional partnership? Second, how does the defection by one partner affect the other partners? And third, what are the drivers of regional instability and why? And so to answer these questions, it's helpful to have a metric that allows us to measure regional stability. And we're proposing one that we're calling cooperative regret, which is the maximum gain or loss in each objective that a utility may obtain through defection without sacrificing performance in other objectives. So we can plot the cooperative regret from our utilities. Here we're looking at the defection from Watertown according to Watertown's objectives. Improvement is shown in green bar and deterioration is shown in purple bars. And we can see that Watertown can financially gain from defection. If we look at the impacts of Watertown on the other 2 utilities, we can see that Watertown defection can actually have pretty severe consequences for Fallsland in terms of infrastructure investment. And if we look at the defection from the other 2 utilities, we can see that, first of all, here's Dryville's defection. And we can see that it has an incentive to defect from the regional partnership, and that its defection actually has dire implications for Watertown, the supplier of these treated transfers. We can see that Fallsland has similar impacts of defection. And so to summarize that, all 3 utilities have an incentive to defect, and there's strong tension between the buyers and the sellers of treated transfers. So I'll wrap up pretty quickly, but first I want to quickly talk about why does this happen. So here's Dryville's rule set under the compromise solution. If we examine what it would like to do under one defection scenario, we can see that Dryville seeks to increase its reliance on short-term drought mitigation, primarily through increasing its use of treated transfers and increasing its Lake Michael allocation, and that it also decreases its use of its infrastructure trigger. We see a very similar thing for Fallsland, and Watertown a bit more subtly also decreases its infrastructure trigger and increases its use of water use restrictions. Now, the final thing I want to talk about is what are the impacts on the pathways. So here are the original pathways from this compromise solution. We can see each of our utilities is using a fair amount of infrastructure investment. If we look at the Dryville defection scenario, the one thing I want to highlight is that this middle box, Dryville's pathways, is empty, which means that through defection, Dryville can completely alleviate the need for new infrastructure investment by exploiting short-term actions. So to wrap up, we've seen that short-term weekly management strategies can actually have a large impact on long-term infrastructure pathways. This stability analysis highlights that there are consequential asymmetries between our 3 utilities when cooperative defections occur, and this can really allow us to measure the impacts on dynamic and adaptive cooperative agreements and think about how we can use this information to create more robust and stable pathways. And I'll wrap it there. Thanks for listening. If anyone wants to download this presentation, you can scan this QR code.
Wow, that's hip. Oh, thanks for this very interesting presentation. Can you move one? Oh yeah, so everyone wants to scan your QR code maybe. I wanted to look at your takeaways also. It was interesting to see that you make a link between like the short-term, more like operational decision-making and the long-term decision-making.
Right.
I think one of your takeaways was also that this can have a large impact, right? Yeah.
Correct.
So what would be your recommendation then if people want to do the pathways?
Yeah, well, I mean, one thing we've seen in working with different water utilities is a resistance to model both short-term and long-term decisions. Oftentimes, agencies will have separate models that deal with short-term, drought mitigation strategies in the water supply context versus long-term infrastructure strategies. And what we've seen is that short-term management, as demonstrated here, can have a large impact on how you manage your infrastructure. There's been a lot of good work out of Andrea Castelletti's group in Italy, kind of showing an analogous finding in terms of constructing or designing of dams and operating dams. And so I think a key takeaway is you really can't separate short-term from long-term, and that you might be missing important aspects for your system if you do that.
Yeah, good point. So I see in the chat, I see a question of Nat. Can the defection incentives and costs of others be used to define the penalties associated with those defections?
That's a great question. I think that would be a logical next step to work with these results. One thing about this is we didn't know what the consequences of defection would be a priori. So we didn't actually know that you could have such short-term or such large impacts from changing your short-term actions. So I think that really shows the value of this analysis is this doesn't have to be the end of our work here. We can actually use it to revisit our problem formulation and say, maybe we should put in some type of penalty system that can try to disincentivize defections in this way.
Did you also consider lead time of follow-up actions? Like the time for implementation?
Yes, so we have, especially for the construction infrastructure options, we have permitting time built in, which is one of the uncertain parameters we have in our model, as well as construction time.
Okay, so and did that affect the results?
We saw that that's something actually I'm going to get into probably in the next month or so, is really analyzing the impact of uncertainty and trying to find what are the consequential vulnerabilities and how do those vulnerabilities change when we look at defections versus just the base compromise. What we've found in the past is that mostly demand growth and evaporation rate, so climate variables, as well as the effectiveness of water use restrictions, which is one of our short-term instruments, have the biggest impact on the system, but I'm really curious to see how that changes with the defections.
Okay, and I see in the chat also Tim Reeder, he has been working on I think a guidance document. Tim, do you want to tell something about that?
Yeah, just to say that I did a presentation on it last year at the DMDU session on adaptation pathways with you, Caroline, and just let people know the draft standard, which we're hoping might be a forerunner to a more international standard, is out for consultation at the moment. But great presentations today, really good stuff. Thanks very much.
Okay, thanks. And then there's a question of Jan, do you want to mention it yourself?
I can briefly talk about this. So really cool stuff, David.
Thank you.
I'm really intrigued by sort of combining these ideas of stability with sort of robustness.
Mm-hmm.
But of course, the way you set it up here is you do a search, and then in a separate post-processing step, you assess the stability, which makes perfect sense, but is computationally very expensive. Do you see possible ways or possible avenues for bringing these stability considerations into the analysis earlier on already, so that you search not only for sort of promising solutions in a Pareto sense, but also constrain the Pareto set by already accounting for stability?
Yeah, I think there's a lot of promise in that direction. I mean, I think one thing that we've been thinking about doing is interrogating the minimax formulation and thinking about, is that an appropriate formulation given that you might have these asymmetries in the system? And so we haven't specifically come up with, or tested alternative formulations, but I think that's definitely like a very promising area to be looking into. So I think you're spot on there.
But that's just a quick response, and then I'll shut up. I do think that it's very, very cool to sort of investigate the formulation itself. On the other hand, the minimax formulation that you've been using in this case, and also in the research triangle case, is very, very defendable on ethical grounds, because it actually is an implementation of the Rawlsian difference principle. So, well, anyway, food for thought. Cool stuff.
Agreed. I agree. Thank you.
So, we're actually already at the end of this session. I think it was very interesting also to see these different types of presentation, from like storylines, literature review, and then a modeling study, which can all be used to explore adaptation pathways and to support adaptive planning. So I think already Lisa put in her email address if the other presenters want to do that as well. Otherwise, you can definitely find them, I think, on the website of the conference. And I would like to thank you all for your participation. And I hope to see you in person sometime in the future. Thanks.
Thanks, everyone.
Thanks very much.